Good morning, everyone. Welcome to our final day of press conferences at the EGU General Assembly. We have two more for you today, starting with one on geoarcheology, finding traces of human presence in caves, soils, and landscape. I'd like to remind you that we will start with the presentations by the three speakers, and then we'll open the floor for questions for those here in the room and those watching remotely via the web stream. If you would like to access documents related to this press conference, such as press releases, you can go to media.egu.eu/documents. I'll now briefly introduce the speakers. We have Martin Kiel, who is a researcher at the Institute of Geography at the University of Cologne in Germany. Then we have Ladislav Schmedza, who is an assistant professor at the Department of Ecology at the Czech University of Life Sciences in the Czech Republic. And finally, we have Hamid Matchmashad, who is a PhD researcher at the Geography Lab at the University of Paris Diderot in France. And I'll hand over to our speakers. Thank you very much.
Good morning, everybody. I'm Martin Kiel, and I want to give you a short idea about what we are doing in the so-called CRC 806, the Cooperative Research Center, Our Way to Europe, which is run by a couple of different universities, University of Cologne, University of Bonn, and RWTH Aachen University. It's funded by the German Research Foundation, and it's a project which runs about 12 years maximum time. We are now in the second phase, and we hope to get some funding for the third phase soon. What you see here is a map which depicts the migration route of anatomically modern humans from Eastern Africa towards Central Europe, and that is the main subtopic of our CRC, Our Way to Europe. And as you can see that we have a couple of different projects which are working along this route, and other projects which are not fixed to regions but work more on a supra-regional level. And these projects are interdisciplinary projects by geologists, archaeologists, and geographers who are all interested in this subject. I am from the so-called C cluster, the group which is working on the Iberian Peninsula in northern Morocco. And as you can see, we work with archaeological deposits, archaeological sites, mainly cave sites, in which we find archaeological evidence of early humans. And we also work with geological archives, like lake archives, where we get information on past climate change. And we want to combine these two lines of evidence to reconstruct the paleo-environment and human occupation in this area. One of the most interesting questions, which has been hotly debated on the Iberian Peninsula, is whether Neanderthals and anatomically modern humans met, and if so, where did they meet and when did they meet? We know from genetic evidence that there was gene flow from Neanderthals to anatomically modern humans, but as we think, most probably not in the Western Mediterranean. And we are doing some investigations on that. The evidence we have so far about the timing of Neanderthals in the Western Mediterranean is still a little bit weird. What you can see here on this map is archaeological sites which have been investigated in the past and yielded different evidence for the timing of the late Neanderthals in that area. For instance, in northern Spain, we have late Neanderthals extinction or disappearance, let's say, before about 45,000 years ago, 45 Ka. In the central part, it's around 40 or even 35,000 years ago. And in the south, there has been some publications which assume that the Neanderthals have survived until about 30,000 years ago. So many different evidences. And as we know, the anatomically modern humans have arrived in northeastern Iberia, as you can see over there, at about 42 Ka. We would have to expect that they have met on the Iberian Peninsula. Anyway, there is an under-researched region, which is the central Iberian region, and we decided to conduct a couple of studies at different locations, at different archaeological sites, to apply modern methods for dating, radiocarbon dating, luminescence dating, and also micromorphology to get a better idea about the timing of Neanderthals at these locations, and also on site formation processes, which is important to clarify to get good stratigraphies. So I want to, let's go back one slide. So 5 different archaeological sites are listed there, and I just want to give you one example, the so-called Abrigo del Molino. It is a sequence of about 5 meters in thickness of sediments. And what you can see here on the up right is a picture, an image of the site after excavation in 2015. The red line shows the upper or the lower boundary of the cave roof. And so you can see it was a cavity which was completely filled with sediments, and in some part of these sediments human occupation took place. And this, if we now have a look at the stratigraphic profile, you can see that the lowermost part consists of fluvial deposits, which primarily filled part of the cave. Then we have a sequence of colluvial sediments, then a mixture of colluvial and detrital sediments, and finally the backfill. And the occupation horizons we found are located in the upper part of the sequence. They are somehow sandwiched with sediments which do not give any indication on human occupation. We call them archaeologically sterile. They don't have any signs of human occupation. But in between, we have these nice occupation horizons or occupation layers which hold evidence of Mousterian occupation or Mousterian industry, which is related to the Neanderthal or the Middle Paleolithic. And this can be shown here. These are tools, lithics, which we found at this location, the archaeologists found there, and which are indicative or really specific for the Middle Paleolithic industry. And this means Neanderthals were there. And we, as I said, we also did some micromorphological studies to get an idea about the sequence is really if it's really in situ, or if it has been reworked and the stratigraphy cannot be reliable. But according to our investigations, we think that it's very much reliable. So we have a robust stratigraphy, no reworking. We also did the dating, as shown here. And most important is to note that the time of occupation was in between 44 and 42,000 years before present. We have a very robust radiocarbon chronostratigraphy, and we also have luminescence dates, and we can now, since we know when the time of occupation took place, we can correlate with the climate records we have from that area, or let's say from the larger area, and we can allocate the time of occupation between the so-called Heinrich Stadial 5 and Heinrich Stadial 4, which have been both times of dry and cold climatic conditions in the Western Mediterranean. So it appears that the Neanderthals who were living there in between these two climate events were only rarely present. We had only ephemeral occupation of Neanderthals at that time, and this means that most probably Heinrich Stadial 5 already diminished the Neanderthal populations on the in Western Mediterranean, and then finally Heinrich IV gave them, let's say, the last kick to disappear, and so we don't have any traces left after Heinrich Stadial 4 in the Central Iberian area. So that was just one contribution, and we are trying to get more information about these kind of population dynamics in the Western Mediterranean. We also know that in Central Iberia, the anatomically modern humans arrived very late. It was about 26,000 years ago when the first traces of anatomically modern humans were left in that area. So we have a large gap of occupation between the Neanderthals and anatomically modern humans in this area. Yeah, so just this is my last slide. I think the Neanderthals and anatomically modern humans are not that much away from each other. They look almost alike. And we always have to consider that the so-called archaic European anatomically modern human was not the same as we are now, because we have some genetic evolution during the last 40,000 years. We look somehow different. And now, and actually, our late Neanderthal is also not that much different from us, as you can see on the right-hand side. Thank you very much.
Okay, I will quickly change the presentations. Hello everybody, good morning. My name is Ladislav Šmejda, and we are presenting today in a geoarchaeology session a poster titled Ashes to Ashes, Dust to Dust, Geochemical Signals of Mortuary Areas. And we investigate the long-term environmental impact of human remains. Of course, we are living organisms, so we accumulate certain elements and compounds in our bodies during life. And when we die, we give these elements back to the nature. It can be a slow or fast process, it depends. And this investigation is part of the Deep Dead project that is funded by the Humanities in European Research Area Agency and co-funded by the Horizon 2020 program. It's a collaborative, international and interdisciplinary project with participants from the UK, Germany, Austria and the Czech Republic. We found that chemical traces of decomposed bodies can frequently be very well distinguished in soil against the natural background values, which is probably not that much surprising, but these traces persist for a very long time, for centuries to millennia, no problem. And of course, we need to consider that not only soil, but also other resources are affected by human burial practices or burial customs. It's not just soil, it's also water, air, it's also space, of course money today. So it's a very complex phenomenon. Unfortunately, it's kind of taboo today in developed societies to speak about death and about last things of human beings. But we feel that it's important to open these questions, especially when more people are living today on our planet than ever in history. And it inevitably implies that there will be a steadily increasing impact of human burial practices on the environment. So our research should contribute to a debate if we are ready to embrace a challenge that human burial presents for the environment and for societies. And certainly there is a potential to invent, to develop, and to put into practice probably new ways of human burial or new treatments that could be more environmental friendly, more ecological. And I'm going to show you a few pictures, a few slides. You can see here that human burials, for instance, in the middle picture in the bottom, can really be distinguished in vegetation. The dots that you can see there are graves, and they can be detected by remote sensing, for instance, or by surface survey. And it's clearly visible that old graves that can be 1,000, 1,500 years old still affect contemporary vegetation. These graves can be excavated and studied in detail. And of course, because there are various burial customs, various customs were developed and invented by human societies over time, we try to study different types of funeral customs. One of them is so-called excarnation. That simply means exposure of bodies to the elements, and people just let nature do the job in open air. And we study this type of funerary practice through animal proxies, because it would not be ethical to use human bodies, of course. But as an approximation, it's okay. And we found that the soil under animal skeletons that we could find on the ground are really affected by various nutrients, various chemical elements. For instance, there are elevated concentrations of zinc, sulfur, or phosphorus. And these elements are, through time, uptaken by plants and released into environment. Then we have an example of an inhumation, that is a burial in the ground, of course, very typical for European societies in the prehistory and medieval period, and it lasts until the present time. And this picture presents a grave that is dated to medieval period. So it can be approximately 1,000 years old. And we can still measure the chemical traces of decomposed soft tissues in close proximity to human bones. And we found, again, significantly elevated concentrations of phosphorus, iron, and zinc in these burials. And the last set of pictures presents another type of burial practice, which is a cremation. We measured human ashes and also their effect on the soil in scattering gardens, in cemeteries, in graveyards. And again, it's maybe not really surprising, but we don't normally consider this, I would say, that human ashes from cremation are composed of calcium phosphate. That's the major part, chemically speaking. And that means that calcium and phosphorus are, again, concentrated in scattering gardens, in the soils there, to a high amount. So in our control soils outside cemeteries, we can find something like, let's say, 1 or 2% of phosphorus. But in these scattering gardens, it's something between 6 to 12%. So it's really multiplied values. And this effect on soils and also other resources, as I said before, are really long-term effects. So what we do today with our debt will affect environment for a very, very long time, because we could see before in my presentation that these traces of human burial can be found after hundreds or even thousands of years. So it's a message for us to consider our present day and future practices and behavior so that we potentially direct our impact on the environment in the right way. Thank you.
Good morning. So I'm Rémi de Matos Machado from University Paris Diderot, and I am PhD researcher, and my PhD consists in studying the Verdun battlefield from a geomorphological point of view, which means that I am working on the man-made landforms and especially military landforms. So, contrary to the image of the Verdun battlefield as a chaotic landscape made of craters and ditches, the Verdun battlefield is today a large forest of 10,000 hectares, which is called the Verdun Forest. And in the context of the centenary celebration, in 2013, a Lidar mission, which means an airborne laser scanning, has been conducted here in the Verdun Forest, and it allows us to reconstruct a 3D topography of the battlefield. So if we zoom on this site, which is called the Ormond Wood, we can see that this technology is very relevant in forested land as the Verdun Forest, because it gives us the possibility to see what happens beneath the forest cover. And so here you can see a lot of war remnants. So it is an image made of black features, and those black features are hollow landforms. And we can make map of landforms. So as a geographer, we can make those kind of document, and we can easily detect features like fire trench, so here in a linear feature, and also shell holes, which are circular features, and so on. This kind of document, those maps are very important both for archaeologists and foresters, because they can locate a sensitive area in terms of history and natural heritage. So I will come back on it after this presentation of the landscape evolution. So the first thing you have to know is that after the war, the French government decided to expropriate all devastated lands, and so it represents all the red zones, so which means the heavily devastated lands along the western front, so which comes from the North Sea to Switzerland. And all those devastated lands have been planted. So in the 30s, especially in the region of Verdun, we have 36 million of trees which are already planted. So from this moment, we can say that the Verdun Forest was born. And because of this forest cover, erosion decreased. And so today we can see that the topography inherited from the war has been saved. So this is really important with LiDAR to map all those landforms. So you know the last step, it's in 2030, the LiDAR missions. which gives us this opportunity to map conflict-induced landforms. So why the geomorphological approach is relevant for us? This is the first example. It is relevant because each military facility has its own shape, its own geometry. And so, for example, trenches are linear, shell holes are circular, or shelters are rectangular, and so on. And we know that because we went on the field site with archaeologists. So we observed the landscape, we found artifacts. So for example, when we found bottles inside a rectangular landforms, finally it was a live place, so it was a place for the soldiers. So finally this landform was a shelter. So this is the kind of interpretation we make. And after we can make those kind of global maps here in the Hornmoon Wood, and actually this represents a German camp made of fire trenches in red, of observation quarters or gun positions. Another example of the geomorphological approach is to locate the fauna habitats. So there is a local geology which is made of limestones, composed of water tables, and the war and especially bombings caused the rock to be broken, and so release the water. And so during the winter today we can see a lot of flooded shell holes which cover all the battlefield. And it is very interesting because all those landforms have been colonized by hygrophilous species, which means fauna who like wetland. And it is a case especially of the yellow-bellied toad and the crested newt, who are protected species at the European scale. So to conclude, we can say that this use of the Lidar technology is very relevant on the Verdun battlefield because it increased the number of discoveries. So it increased from several hundreds to several thousand war remnants. And the other point is that those maps helps us to better understand the forest of Verdun and the history of the Verdun battlefield, especially during the Battle of 1916. Another point, in addition to those discoveries, is that this PhD helps us to locate sensitive area in terms of natural environment. And so those maps are important because they will be used both by archaeologists and foresters in order to propose new methods of management in the forest and to preserve the topography of war. Thank you for your attention.
Thank you very much for the fascinating presentations. We'll now open the floor for questions. Are there any questions from the journalists here in the room or from those watching us remotely? I know there's one on the web stream, but I'll...
Thank you. Hi, I'm Mariette Leroux. I'm with Agence France Presse. For Martin, I was wondering if you could speak a bit more about what it means for what we know about our own species, your conclusion that we did not meet Neanderthals in central Iberia.
Yeah, there has been a very long scientific debate about if they met or not in the Iberian Peninsula, and many theories have been developed on the first evidence we had from radiocarbon dating, for instance, for very prolonged survival of Neanderthals in the south. Maybe you have heard about the Ebro frontier theory and hypothesis, and many other things which have been discussed. But now it seems that this evidence was not reliable. And I think we need more studies which really go into detail on site formation processes and also apply new dating methods to produce reliable results. And I think that's one of the main topics of geoarchaeology, to do this, to combine the expert knowledge from different fields and bring the results together. And so in other parts of the Mediterranean, in the Eastern Mediterranean, there are some evidence, there's evidence that the early anatomically modern humans met Neanderthals, at least from a contemporaneous occupation. You can get this idea. And also we have the information from the genetic studies now that all of us bear a couple of % of Neanderthal genes inside. So we know that about 4% of our genes are directly related to the Neanderthals. And so we need more reliable dates to really check these different hypotheses which are behind that. And as long as the Western Mediterranean is concerned, we could figure out now during the last years that, first of all, there was most probably not a meeting, or no, they did not meet in that area, and also that the anatomically modern humans who came from the Eastern Africa region, they went up to northern Morocco, or to Morocco, that area, where they arrived already at 170,000 years ago, but then they did not cross the Straits of Gibraltar. They stayed on the other side. We don't know why, but there's no evidence which would show that they did this crossing. You know, it was a barrier for this dispersion process of the people. Yeah, and so the Neanderthals, which were already at on the Iberian Peninsula, they were not touched by these early humans, modern humans, but later the modern humans came from the north.
Thank you. Are there any other questions from those here in the room?
Hi, Remy, could you just describe the Lidar technique? Because that must bounce off the top of the canopy, doesn't it?
Yeah.
So how do you see the ground features?
So there is several techniques for LiDAR, and this one is the airborne LiDAR, which is a LiDAR on the plane. And so a laser beam is sent toward the surface, toward the ground. So it gives us several models. So the first is the canopy model. So we don't have it here, but it gives us the image of the summit of the canopy. And then, because of the wavelength, it is possible to cross the canopy and to see what happened beneath the soil, beneath the forest cover. And so this is the DTM, the digital terrain model, which is shown here. Yeah.
So you subtract the trees, you take the trees away digitally.
Yeah, that's right. That's right. But sometimes we have mistakes inside the classification. So for example, we can found trees on the ground, but yeah, it's a problem of classification. So we have to work to improve it.
Thank you. Yes. And I have one for Ladislav as well, please. The chemical traces that you talk about and that you found, are these necessarily bad for the environment? And what alternatives are you suggesting?
Well, of course, they are not bad as such. They can be also positive factors because they are necessary nutrients for life. But the question is if it is a good idea to accumulate in such high concentrations these nutrients in very limited patches of land, or if we can come up with better ideas how to distribute these necessary elements across wider landscapes. And of course, it's a very complex problem. And I would also like to point to the fact that, for instance, cremation does not only produces this highly elevated concentrations of phosphorus and calcium at certain places, but it also consumes a large amount of fuel. Today it's fossil fuel mostly. There are atmospheric emissions of carbon, nitrogen, also mercury from dental restorations, for instance. So it's a real environmental problem that should be considered. And you asked for possible alternatives. Of course, there are companies that try to develop new techniques. And one possibility that I personally like is a company called Promessa. It's a Sweden company. And they proposed deep freezing of bodies by liquid nitrogen, then using gentle vibrations to turn the body into dust, then cryogenic removal of water, because water is a major component of our bodies, and what remains is a perfect biodegradable powder that can be buried anywhere. And what is particularly nice, that you can, for instance, plant a tree on that grave instead of, I don't know, a stone monolith or something like that. So for me, it's a nice perspective that I would turn into a tree, and I think it's a very beautiful idea. But of course, it's not that easy to put this into practice. There are also problems that even this technique consumes a lot of energy, because for liquid nitrogen, etc., you need a lot of energy. But this energy can come from renewable sources. That's important. Thank you.
Sorry, we have a related question also for Ladislav from the web stream. It's from Christina Reed, freelance. So she asks specifically about calcium phosphate. Are there areas where calcium phosphate would be of value to the environment?
Would be
a value to the environment?
Value, well, I think it can be used in a long-term perspective by plants as a source of nutrients. But the problem is, I will repeat myself, that we maybe put this resource without much thinking in very limited places. And the question is if our current values, if we as a society want to continue this practice, or if we will decide at some point that maybe some strategies would work better for the environment and for the societies as well.
Thank you. Are there any additional questions from the journalists here in the room?
Thank you. Bastian Hond, EOS magazine. I can understand that maybe there's an environmental problem with our remains, but aren't you exaggerating the problem of energy use? If for a lifetime I've been flying around in airplanes and driving cars, then surely I should be allowed a little bit of energy to be disposed of. And in view of what I've used all my life, or saved, maybe, it's nothing.
Yes, this is of course a matter of perspective. Now we are trying to develop electric cars, new ways of transport. Of course, it will take a lot of time and effort to put everything in practice. But why should we leave this aspect alone? I think it's a valid problem in its own, and maybe it's not such a problem in our current perspective, but with an increasing population globally, it might become a pressing problem in the future. And I think it's better to be prepared, to have some strategies, and certainly at least some people might want to choose more environment-friendly way of living and even of dying, and maybe to contribute to the environment with their own bodies. And if other people don't want to do this, I think it's okay, because we cannot prescribe anything, especially in these very personal matters that are frequently deeply influenced by traditions, religious practices, etc., etc. So it's a part of our identity. So I said that it's a very complex matter, and we are just at the start of this discussion, I think.
Thank you very much. I think we have to finish here, I'm afraid, because we have another press conference coming up at 11 on food security, how extreme weather and other events affect what we drink and eat. Thank you very much for coming, and thank you very much for the presentations again.